Hi friends, are you finding chemical reactions and equations difficult? Are you finding it hard to balance chemical equations? Don't worry, because in this video, I'm going to make it really easy for you. We are going to discuss important questions on chemical reactions and equations in this video. So be sure to watch the entire video and I'm going to show you the tips and techniques on how to solve the questions. All right, friends. So are you ready and excited for this topic of chemical reactions and equations? And guys, before we start, I'd like to say that do check out our website, manochaacademy.com. We have these courses on physics and chemistry for class 9 and 10. And we'll also soon be launching the maths courses for class 9 and 10. So do check out these courses. The links are given below because you'll get to watch interactive videos, attend special live classes, and there'll be quizzes and questions. All right, guys, so do check it out. And if you haven't subscribed to our YouTube channel, Manocha Academy, hit the subscribe button right now and click on the notification bell so that you don't miss out on any of the live classes or the videos that we upload. So thanks, guys, a lot for your support, and do share it out with your friends so that we have more people joining the Manocha Academy family. All right, guys, let's dive right into our quiz. Here's the first question. What is the type of the reaction for the one given below? Zinc carbonate breaks to form zinc oxide plus carbon dioxide. So on heating, zinc carbonate forms zinc oxide and carbon dioxide. So guys, what do you think? Is this a combination reaction, a decomposition, a displacement, or a double displacement? Come on, what do you guys think? Okay, very good. I'm seeing a lot of answers here. So yes, I want all of you to be replying to the answers in the chat. So it's great to see so many answers. So let's see how to analyze this. And guys, if you haven't hit the like button, please hit the like button right now and share it with your friends. So if you take a look at this reaction, zinc carbonate. So we have zinc carbonate and on heating. So when we heat this guy, it breaks down into zinc oxide plus carbon dioxide gas, right? And if you look at it, it can't be a combination reaction because in a combination reaction, we have only one product. But here can you see that we have only one reactant here. So one reactant is giving rise to many products. So we have two products here. And what is that type of reaction? Very good. Excellent. I see the right answer. It's a decomposition reaction because can you see zinc carbonate is decomposing, right? It's breaking down. So it decomposes, it splits to form zinc oxide plus carbon dioxide. So what is your clue? If you have only one reactant and many products, then it is a decomposition reaction. Excellent, guys. You guys rock. Let's look at our next question. Write the chemical equation for the word equation given below. Okay, so here I want all of you to try. I've not given choices here because I want you to try and write down the reaction for me. What do you think this is going to be? And a lot of people have this difficulty in converting the word equation to a chemical equation. So here, can you see we've been given this word equation. Iron plus hydrochloric acid gives ferrous chloride plus hydrogen. Okay. So come on, guys, please try. So I see some answers from Tejinder, Shreyash Kumar, very good. Sanya Garg, very good, guys. So please go ahead and try. Isaac Newton, he has some answer here. So let me show you the technique. How do we convert this into a chemical equation? So guys, please follow me carefully. So let's go step by step. The first one, iron. So is iron an element or a compound? First you think about that. So iron, we know it's an element. So let's write down the symbol iron. And for elements, guys, so let's write down the rule here. So for elements, so let me write it down here. So for elements, we need to use atomicity when writing the molecular formula. Okay. And you've learned about atomicity in your previous classes. And for compounds, we need to use valency. Okay. So iron is an element. So and atomicity of metals like iron is 1. So it's simply Fe, right? So pretty simple. So this is just going to be Fe because the atomicity is 1. Now the next thing, hydrochloric acid, you know hydrochloric acid is a compound. So we need to write its formula. So it's a compound of hydrogen and chlorine. And for compounds, we need to use valency, guys. So the valency of hydrogen is 1, chlorine is 1. So if you do crisscross, the formula comes out to be HCl. So please write your formulas very carefully. And this L should not look like a capital L. So I'm going to erase mine and write it again. It should look like a small l, right? HCl. Because first letter capital of the symbol, second letter small. And then we have ferrous chloride, guys. So what is the formula of ferrous chloride? So again, it's a compound. So Fe and chlorine. And now we are going to use the valencies, right? Because it's a compound. So let's write down the valencies of it. So let me write Cl clearly here. So iron, the clue is in the name, ferrous, right? Iron has 2 valencies, 2 or 3, right? You guys know iron can have 2 valencies, 2 or 3. So here ferrous means we are going to use the valency of 2 because us is the lower valency, ic means the higher valency. Okay, so guys, it's not going to be FeCl. I'm seeing some of you are writing FeCl. No. So please analyze it. Ferrous valency 2, chlorine has a valency of 1. So if you do crisscross, what do you get? FeCl2, right? It should be ferrous chloride is FeCl2. Very good. I think Albert Einstein, Jemmy Alex, right? You guys have the right answer. FeCl2, Ayush Mokal, right? Very good. So be careful about that. Now, how do you represent hydrogen? So can I simply write H for hydrogen? Because hydrogen is a element. So can I just use the symbol H? No, right? Very good. Many of you have written H2. Why? Because guys, the atomicity of hydrogen is 2. For elements, you need to use atomicity. So one molecule of hydrogen contains 2 atoms. That's the meaning of atomicity. So look here, guys. Iron is an element, but it has atomicity of 1. So one molecule of iron is simply Fe because the atomicity of iron is 1. And hydrogen, the atomicity is 2. So it's going to be H2. So very important. I want you guys to be crystal clear about this. I've given you the simple way. For elements, guys, analyze it. Is it an element or compound? For elements, use atomicity. For compounds, use valency. Simple. Okay. And this is the equation. Is my equation absolutely right, or is there something I need to do? So come on, guys. Is my answer correct? Fe plus HCl is FeCl2 plus H2. Okay. A lot of you have written that answer, but is there anything wrong in that? Okay. I think Nevedita says no. So Chandan Kumar says wrong. What is wrong about it? Yeah, very good. So Jaya Reddy says we need to balance the equation, right? So guys, don't forget to balance your equation. Even if it doesn't say write a balanced equation in the chemistry test. I remember I used to enter the chemistry exam hall saying balance, balance, balance. Because you shouldn't forget to balance and don't learn up balanced equations, okay? You should balance it on the fly, okay? So you should learn how to balance these, and this one is pretty simple because we have 2 hydrogens, so we'll multiply by 2. So our final answer is going to be Fe plus 2 HCl gives FeCl2 plus H2. If your school asks you to write the physical states also, you should write that. But for this question, we'll leave the physical states and write this final chemical equation. So is this clear, guys? The important rule when converting from a word equation to a chemical equation, please use these rules that I've given you. For elements, use atomicity while writing the molecule. For compounds, valency. Crystal clear? Excellent. Let's move to the next question. So guys, you've seen all these railings, right? They rust, right? Bridges rust, ships rust. So can you tell me what is the formula of rust? So I've given you some options here. So can you tell me what is the correct formula of rust? Come on. So I want all of you to try. Very good. I'm seeing a lot of answers here. Great. Some people are saying B, C, D. Okay, this is exciting. We are getting a lot of answers. Fe2O3, B, okay. So one thing to be clear, guys. So again, remember iron has 2 valencies, ferrous or ferric, right? It has valency 2 or 3. So rust, you guys should remember this brown color thing. Can you see? This is the rust on the railing. Can you see the rust here on this railing, on this iron railing? And you know that iron slowly corrodes, right? It reacts with the oxygen. So iron basically, so we know that for rusting, iron plus, I'm just writing it roughly, iron plus oxygen plus moisture, right, or water, they react to form our compound rust. right? Which is this orangish, reddish orange color thing, right? And so the compound rust is basically, so you need to know that rust is basically ferric oxide, first of all. So it's not ferrous, it is ferric oxide, and it is, in fact, it contains water. So it is hydrated ferric oxide. There's some water attached to it. So what is the formula of rust? It is Fe2O3, because ferric oxide means valency. So look here, guys. Ferric oxide means, how do we write its formula? Ferric means valency of iron is 3. Okay, and oxygen, you know the valency is 2. So if you do a crisscross, what do you get, guys? So you're going to get Fe2O3. Okay, so it cannot be ferrous oxide. So this option is wrong. This option is wrong. But even B is wrong because there is some water attached to it, right? So very good. The guys who've written D, D is the right answer because there is some water attached to this ferric oxide, and that is why we write Fe2O3 dot XH2O. Okay, and why do we have the X in there? Because the number of water molecules vary. I think typically the range is from 5 to 7 or 4 to 7. You guys can check in the book, right? So there's a range of water molecules. It's not always fixed. So it can be like, for example, 5 water or 6 water. So Fe2O3 dot XH2O. Okay, so it is, right? It is a variable number of water molecules attached to ferric oxide. Excellent, guys. So please remember, when you're asked to write the formula of rust, Fe2O3 dot XH2O. X because it's variable. Super. So now try this question. Which chemical equation or which equation below represents the electrolysis of molten sodium chloride? Okay, so I want all of you guys to try this. So which equation represents the electrolysis of molten sodium chloride? Okay, excellent, guys. Please try. Oh, somebody's asking what's my name. So my name is Sandeep Manocha, right? Come on, guys, I want you to try this question. And if you haven't subscribed to our YouTube channel, Manocha Academy, please hit the subscribe button right now and hit a like for this video, and do share it out with your friends so that we can have more folks joining us in these live classes and watching the videos. Okay. Where am I from? I am from Kolkata, India. So I stay in Kolkata, India, guys. That's where I'm living. Okay, guys, give me the answer of this question. Come on. Awesome. You guys are really interactive. Excellent, guys. I'm seeing a lot of answers here. So what is the clue in the question? First of all, electrolysis, right? So electrolysis, you know, it's basically decomposing the compound. So electrolysis means decomposing using electricity. Okay. So you pass electricity through the compound to break it down. Okay, so that gives you the clue that these can't be, because the first two options you can see are combination reactions. Can you see? Multiple reactants are forming one product. So A and B is out, right? It's either going to be option C or D. Now, guys, can you tell me which one is it, C or D? So let's analyze. So first, let's write down our equation here. So electrolysis of molten sodium chloride. So basically we have NaCl on the reactant side. And when you have electricity pass through this, right? So we're going to pass electricity, or we say electric current is passed through it. It breaks down into sodium and chlorine. Okay. And chlorine, sodium is monoatomic. It's a metal. So we don't write Na1, right? It's simply Na. So I'll just write Na. But chlorine will be Cl2. Note all these important points. Don't write Cl. Okay. It's going to be Na plus Cl2, right, guys? And of course, we need to balance our equation. So we have it balanced now. Now the important thing is what physical states to write here. So good. Some of you are saying C or D. What do you guys think here? Okay. So clearly sodium is a solid. So this physical state is going to be S. Okay. And chlorine is a gas. So this guy is going to be G. Okay. Chlorine, you know, is a yellowish green, greenish yellow colored gas, right? And sodium is a metal. It's a solid here. So it's represented by S, right? What about molten sodium chloride, guys? Do you know what does this word mean? Molten. So is it going to be AQ or is it going to be L, liquid? What do we write? Okay. So please understand this. These are very important, and there's always confusion about this. L means liquid and AQ means aqueous. Okay. So aqueous means dissolved, something dissolved in water. So typically this means aqueous means it is dissolved in water. Okay. And so here when they are saying molten, they're not talking about aqueous sodium chloride. Molten sodium chloride means liquid, liquid sodium chloride. The word molten here means liquid. Okay. And that means sodium chloride, you know, is salt, right? We know that's the salt that we eat. So, sodium chloride salt is a solid, but you heat it up so much that it becomes a thick, mushy liquid. Okay. So it becomes a thick liquid, and that is why it is called molten sodium chloride. And so this will be represented by L, because there's no dissolved in water here. It is just melted using heat. So molten, basically you can learn, actually means melted. Let me write that word also. So are you clear? So molten means melted, and it is melted by heating it. And that is why the answer, excellent guys, superb, it will be D. So since the question said that we are using molten sodium chloride, not aqueous, it will not be AQ. Superb guys. So the correct answer here is option D. Very good. Now come on, try your balancing. Here I have not given you any options. So I want you to use your pen and paper, and all of you, please try to balance this chemical equation. We have magnesium nitride plus water gives magnesium hydroxide and ammonia gas. So all of you guys, please try. Great to see all of you here. And I see a lot of folks are out here, but I see only 109 likes. Come on, can I have a like from each one of you here? So guys, can I get some more likes here? And go ahead and try this, balancing this equation. Come on. Yeah, thanks. Great, great. I see more likes. Thank you guys. And please try balancing this equation and let me know your answer in the chat. Awesome. You're saying what is my job? My job is, my teaching is my passion, and my job is to teach, you know. So I love teaching. Great guys. So come on. Define electrolysis. I just said in the previous slide, right? It is decomposing by using electricity. Guys, here's the definition written. So by using electricity, you decompose the compound. Okay. So come on, guys. I want all of you to try balancing this equation. So let's write it down. Mg3N2 plus water gives magnesium hydroxide, MgOH whole 2, right? Plus ammonia. NH3. Ammonia is NH3, right? Okay. So now we can try different balancing techniques. You can watch my video. You can search balancing chemical equations by Manocha Academy, right? And so always good to try the hit and trial technique. Of course, you can use the table method if you like the more formal to write down the thing, to write down the number of counts of elements on the left and right hand side, right, of the atoms. But let's try the hit and trial technique because it's the fastest. So come on, good. I see some answers here. So what do we try here? Can you see there's 3 magnesium and only 1 magnesium here. And in the hit and trial technique, always try to balance the easy elements first, right? What you can easily balance. So I think magnesium is pretty easy to balance because we have 3 here and only 1 on this side. So let's multiply this guy by 3. So magnesium is balanced for us. Okay. And now nitrogen, can you see is 2 on the left? Can you see the N2 here, guys? So there's N2 here. And how many nitrogen do we have on the right? Can you see? 1. Okay. So if you just write that down roughly for you. So nitrogen is 2 on the left here. Can you see? And nitrogen is only 1 on the right. So to balance it, we'll need to multiply by 2 here. Okay. So hopefully that should balance our nitrogen also. Now let's see what about we have hydrogen and oxygen left to balance. So let's count the hydrogen on the right side. Okay. So hydrogen, you can see there's H here and this is 3 times 2, right? So that's going to be 6. Note here carefully. So this is OH2. So 2 hydrogen and there's a multiplier 3 here. So that's going to be 6 here. And if you look here, guys, hydrogen is again 3 here times 2. So what is the total hydrogen on the right side we have? So hydrogen on the right is 6 plus 6. So that's 12. And we have only 2 hydrogen on the right. Okay. So to balance it, what do I need to do? I just need to multiply, I think, by a 6 here, right? So to balance hydrogen, we need to multiply by 6, because now you can see the hydrogen is going to be 12 on this side, right? Nitrogen we've already balanced. So by hit and trial, we are going element by element. So hydrogen is now, can you see, 2 times 6, 12 on the left hand side. And this was 3 times 2, so 6 plus 6, 12, okay? And let's take a look at our oxygen, guys. So on the left, we have 6 times 1, so oxygen is 6. And on the right side, how much do we have? Let's see. OH whole 2, so there's 2 oxygen in this bracket, this part. So 2 times 3, 6. Awesome. See, oxygen is also balanced. Did you see, guys? So we just use the simple hit and trial technique, right? So guys, take a look at this. The simplest technique, and I think the equation is balanced. All of you can check. Magnesium 3 on the left, 3 on the right. Nitrogen 2 on the left, 2 on the right. Can you see? So look here. So magnesium 3 on the left, 3 on the right. Nitrogen is 2 here. We have 2 nitrogen here, 2 here. And then oxygen and hydrogen we just balance for you. Okay, superb, clear? So this is how we balance the equation, and using hit and trial, it's the fastest, no need of any table. Try the elements that are easy first. If it gets difficult, then you should use the ABCD method, which I'll also discuss in the class today, right? So there's a very special technique, so stay tuned to look at how to solve by the ABCD method if the balancing gets difficult. But this one wasn't that difficult if you just apply the numbers. Okay, awesome. Somebody was asking, when is the next live class? Usually we are having the live classes at 8 p.m., right? So you guys can check it at 8 p.m. And we also have more live classes on our website. So do check those out also, manochaacademy.com, and you can take a look at our courses. We have special discounts going on right now. So guys, do check it out. Now let's take a look at the next question. A green crystalline solid X on heating produces a brown colored solid and gases with a pungent odor. So guys, can you be a detective and tell me, what do you think is X? So chemistry is all about colors and looking at the clues. So you're basically like a forensic person or a detective and trying to find what is the solid X here. This is the question, right? So come on guys, I want all of you to try. So what's our, let's write this down. What have we been given? That a green crystalline solid, so green solid X. So X is a green solid on heating. So if we heat it, it produces a brown color solid. So let's write that down. So on heating, it produces a brown color solid, brown colored solid, and gases with a pungent odor, right? Plus it's producing gases with a pungent smell. Pungent means strong, irritating smell, right? Not pleasant, okay? So what do you think this guy is? Come on, I want all of you to try. Okay, very good. I see different answers here. So can it be ferric oxide? No, we just discussed ferric oxide or rust, right? It has a reddish brown color. We want to know X, the green color solid. So this can't be our answer. Okay, copper sulfate, you guys know, right? Copper sulfate, if it has water, it's blue in color. And if there's no water in copper sulfate, then it's white in color. So this can't be, because our X is a green color solid. Come on, be Sherlock Holmes, be a detective and think what answer. So we have two options here left. Ferrous sulfate or green sulfate or green vitriol. What do you guys think? Okay, excellent. I'm seeing some of you are saying going for B, some of you are going for C. What do you think the answer is? Okay, so let's see what's the difference. So green vitriol, okay, that looks like a clue. Our answer should be green. Green vitriol is nothing but ferrous sulfate with 7 water molecules. Okay, and ferrous sulfate is simply FeSO4. Okay, and it says crystalline. Look here, crystalline. So you know that we are looking for a solid and it could have a water of crystallization, right? Water of crystallization. So you know that ferrous sulfate .7H2O is the best answer to go for here, and you can check your book also says it is green vitriol having 7 water. So, and when you heat this, it produces, of course, the water vapor will also get released, which wasn't given in the question, but I think the best answer to go for here is Answer C, green vitriol, because it's a crystalline solid and you know that 7 water gives it the crystalline shape. Okay, otherwise if you heat it, it gets a amorphous or a powdery shape. Okay, so the best answer here guys is ferrous sulfate dot 7 water, not B. Go for green vitriol, which is ferrous sulfate with its water of crystallization. Okay, excellent guys, superb, right? Now let's go to our next question. So identify the oxidizing agent in the reaction below. So guys, you need to tell me in this reaction, what do we have? We have hydrogen sulfide. So let me write that clearly here. So our reaction is H2S plus chlorine, right? Gives us sulfur plus 2HCl, right? And you need to tell who's the oxidizing agent in the reaction below. So this is an interesting question. Come on guys, please try. So one option, so how to analyze or attack these type of questions. So like I mentioned in an earlier class also, or let me revise that. So you should always take a look at what is happening in the reaction. So hydrogen sulfide you can see is turning into sulfur. Okay, so let's draw that arrow, and chlorine is becoming hydrogen chloride. Can you see that? Now you need to identify which one is oxidation and which one is reduction. Okay, before we talk about oxidizing agent, first let's see who's oxidation and which one is reduction. So come on guys, I want all of you to try. So what do you think the answer is going to be here? So come on. So hydrogen sulfide turning to sulfur. So what do you think this will be? This is going to be hydrogen sulfide to sulfur. Can you see that's loss of hydrogen? It's losing hydrogen, right? So this is loss of hydrogen. And you know, because hydrogen sulfide is losing hydrogen to become sulfur, so loss of hydrogen is oxidation, right? And chlorine to hydrogen chloride, you can see that is gain of hydrogen, right? Gain of hydrogen. So this guy is reduction. Do you guys agree first with this? Be clear here. Okay, then I'm coming to some of you asking what is oxidizing agent. I'm coming to that. First, you please understand that hydrogen sulfide to sulfur is oxidation because hydrogen has been lost. Chlorine to hydrogen chloride, chlorine is getting reduced because hydrogen has been added. Gain of hydrogen. Clear? So this part is clear. Now, so therefore, if we analyze, we can write hydrogen sulfide is getting oxidized. So from this reaction, we can write this is getting oxidized and chlorine guy is getting reduced. All of you agree with me, right? Anybody having a doubt? This is pretty clear. Okay, right? Very good. And now let's try. We need to identify the oxidizing agent. So one very simple trick is, and I'll explain you why, the guy who gets oxidized, okay? So the guy who gets oxidized is actually the reducing agent because it is helping the other fellow get reduced. And the fellow who gets reduced, okay, this guy is actually the oxidizing agent. So the answer is basically, now for the agents, it becomes opposite. So please understand, very simple, let me explain you. Hydrogen sulfide you all saw here guys, it is getting clearly oxidized because it is losing hydrogen. But it is the reducing agent. Why? Because it is helping his friend chlorine to become reduced. Just like a travel agent helps you travel, right? Travel agent helps you travel. So the guy who gets oxidized is the reducing agent because he's helping the other friend get reduced. Similarly, chlorine was getting reduced, but it is the oxidizing agent because it is helping his friend, hydrogen sulfide to get oxidized. Can you see? So this is a very easy way. Okay, clear guys? So this is the answer, that the answer will be, the oxidizing agent is chlorine. Excellent. I see K. Gautam, Sneha Pandey, very good. You guys got the right answer. Akash Verma, right? Excellent. C. John has got the right answer. Excellent, guys. So chlorine is the right answer here because can you see the guy who's reduced is the oxidizing agent. Okay, so please remember that And always remember who's oxidized, who's reduced, who's the reducing agent, who's the oxidizing agent. It is always the reactants, never the products, right? Because the reactants on the left is what the answer will contain. So it will not be sulfur or HCl. Okay. So this is how you analyze this question by drawing these arrows. Then you'll find it very simple. Clear? Superb. Clear? And guys, if you have doubts, you can put it in the comments. Otherwise, go back and just watch this part again if any question confused you, and I'm sure you'll become crystal clear with it. Great. Now let's try the next question. When iron nails are added to copper sulfate solution, how does the color of the solution change? Does it turn from blue to green, green to blue, blue to colorless, or remains blue? Come on guys, please try. Okay. I know a lot of you are giving answers, and sorry if I'm not able to take each one of your name. I'm trying, but I'm tracking your answers, and very good guys. It's really great to see everyone interacting, and please hit the like button if you haven't hit it. So I want more likes from all of you, and please share it out with your friends so that we can have more people joining the Manocha Academy family. All right, excellent. I see many answers here. So let me show you the trick of how to analyze this question. So in chemistry, always think in terms of reactions, right? So iron nails are added to copper sulfate. So Fe plus copper sulfate, right? So what do you think the reaction is going to be? Iron is more reactive than copper, so it's going to displace it. So we are going to get FeSO4, ferrous sulfate plus copper. Do you guys agree with this reaction? Simple, right? Iron plus copper sulfate gives ferrous sulfate plus copper. So now let's try writing the colors, right? So we are interested in iron, of course, you know, is grain color. So these nails are grain color. Copper sulfate solution, you know, we just talked about copper sulfate is blue vitriol. So this is a blue colored solution. And ferrous sulfate, right? It's basically ferrous sulfate solution is green in color. Okay. And copper, you know, is a reddish brown, or orangish reddish colored, right? Solid. So we can write here reddish brown or orange, right? Reddish orange color is copper. Clear? So first write down the reactions and then analyze it. Don't just jump to the answer. So always think in chemistry. The clue is think in terms of the reaction. Think of what colors you know. And guys, learning the colors is very important. Every time you see a color given in the book, please underline it and learn it up. I remember in my school days also we had to keep learning all these colors because it's not that you see these compounds every day, right? So you have to do some memorization of colors. And now clearly guys, you can see the solution, because this is copper sulfate solution. So this was the aqueous, right? It has changed from blue to and the green colored solution. This is also in aqueous. So guys, you can clearly see the color changes from blue to green. Excellent. Many of you have written A is the correct answer. Superb guys. Copper sulfate blue, ferrous sulfate solution green. So the color changes from blue to green. And this type of reaction is displacement, where iron is kicking out copper, displacing copper from copper sulfate. Very good. Now guys, I have another interesting balancing for you. Ammonia plus chlorine gives N2 plus ammonium chloride. Okay. This one is a little more difficult. So you can try the hit and trial. So you might get it quickly. But I would suggest all of you, because I'm going to show you the ABCD method. So many of you might have watched my video also already on this. So if you don't know it, I'm going to revise this for you. So let's try the ABCD method on this, because this equation is a bit difficult to balance. And you'll see that when you try hit and trial, the numbers are getting a little confusing. Okay. So come on guys, please try. Excellent. A lot of you got that answer, blue to green. Superb. So come on, I want all of you to try this. And awesome, great to see so many likes. I want everybody to give us a like and please share out this video, okay? So let's try this balancing using our fantastic ABCD method. So this method is really good because any difficult equation you can balance it, and I'm going to show you in a really simple way, okay? So first let's write down our equation. Ammonia plus chlorine gives nitrogen plus ammonium chloride. Of course, first you should try the hit and trial like we did earlier, but you'll see that this one is a bit difficult. So we'll directly go to our ABCD method. In ABCD method, you first put down the coefficients, okay? So since we don't know these balancing numbers, we call them coefficients here. and you just put down A, B, C, D. If there are more things, you can put down E, F, and so on. Clear? So guys, write this down. Now let's look at the interesting part, how to balance. So how to find these numbers. These A, B, C, D are like X, Y in algebra, right? We don't know what is the values of these. And once we get the values, our equation is going to be easily balanced, right? So everybody got this? So now let's see how to balance it. So my suggestion here is you just make a simple table with the elements, and then we are going to write the equation for the elements, right? So what equations we are getting? So what are the elements in this equation, in our chemical equation? Let's write down. So we have nitrogen, we have hydrogen, and chlorine. Okay, those are our three elements. Clear? Okay, so now guys, please, this is very important. So carefully follow me, and I'm going to make the ABCD method really easy for you. Okay, so take a look at, focus on nitrogen first. That's our first element. Okay, we are focusing on nitrogen. So how many atoms of nitrogen do we have on the left? Okay, so take a look, how many atoms of nitrogen? You can see nitrogen is 1 in ammonia, and it's A times, right guys? So it's going to be, so this equation is going to become A equal to, so A on the left, and on the right, how many of nitrogen we have? You can see it's 2 times C, because N2 into C, plus this is D. So can you see that we have 2C plus D here? Does everybody follow me? For nitrogen, it's going to be, so please take a look carefully, because we put all these coefficients A, B, C, D. Now we need to write our number of atoms based on that. So we are equating the left and the right hand side only for nitrogen first. Okay, so it's A nitrogen, and on the right it's 2C plus a D. Okay, because 1 times D, right? So this is, now for hydrogen, I want all of you to try, guys. So what is it going to be for hydrogen? How many hydrogen atoms on the left? Come on, guys. So are you all with me? How many hydrogen atoms on the left? So can you see how many hydrogen atoms on the left? It is going to be, so look here, there's 3 hydrogen in the ammonia times A, right? So don't forget A. So on the left hydrogen we have 3A, and on the right hand side, how many hydrogen we have? So this one doesn't have any hydrogen, 4 times D. Okay, okay, so not 3A guys. Okay, be careful, because we have written that multiplier A. Since we don't know the balancing, these A, B, C, D are our variables, right? We have written the coefficients there. So this is going to be 3A equals 4D. And finally for chlorine, it's going to be 2 times B on the left. So 2B is equal to D, right? Because we have D chlorine atoms on the right side. Very good. So look, we have these 3 equations, and now basically we need to solve these. So let me show you. So how do we solve them? First, one very important thing is, you can assume, or you can let any of one of the coefficients be 1. And you should take the coefficient that occurs the maximum number of times to be 1, so that it will be much easier and faster to solve these equations. Actually, you can take any one, but take the one which is occurring the most number of times. Now, which one do you think is occurring the most number of times here, guys? Take a look. So in all these 3 equations that we have here, can you see that D is occurring the most number of times, 3 times. So D is present in this equation, and this equation. A is only present in 2 equations, B is present only in 1, and C is present only in 1. So we are going to say let D equal to 1. Okay. So to solve it, we are taking D to be 1. Now we can use this equation. So we can say 2B is equal to D. We have got, so I'm using this equation 3 here, guys. So this is our equation 1, 2, and 3. So using 3, I can find B very easily. 2B is equal to D. Therefore, B is basically D by 2. So that's going to be half. Simple, very easy, just substituting the values. Now using the second equation, let's see, we can solve for A. So from the second equation, we have 3A equal to 4D. So therefore, or 3A is 4 into 1, 4. So therefore A is turning out to be 4 by 3. Do you guys agree with me? So in case you have any issue, just check my calculation, right? So if I'm making any mistake with my numbers, please check it. And what about the last one? We need to find C. So for that, we are going to use the first equation here. So let's write it down. A equals 2C plus D, right? So let's substitute the value. We need to find C. So A we had 4 by 3 is 2C, and D we took as 1, right? So plus 1. So therefore we are getting, or from here we are getting 2C equals 4 by 3 minus 1, right? Which is nothing but 1 by 3. So therefore C equals 1 by 6. So all of you got that? So guys, take a look. We found these numbers. We let D equal to 1. We have found B equal to half from here. We have found A equal to 4 by 3, and we have solved for C. So basically, take a look at this very easy, very powerful technique. If you can't balance any equation, you can use this in the exam and solve it in 1 or 2 minutes. So you won't have to worry about balancing any equation. All we did here, guys, we put the coefficients A, B, C, D, and if there are more things, you can put E, F, and so on. So we put A, B, C, D here. We let the coefficient that occurs the maximum number of times. We let D equal to 1. Here, D occurred the most number of times. And using these equations, we just simply had to substitute and solve them. Or sometimes you might have to solve a pair of linear equations in 2 variables. So you just solve them, you get the values, and now you just have to substitute it in your final equation. Clear? Right? How can you form the equation? Nothing. You're given the equation, you just add A, B, C, D. Oh, how do we form these equations? So you go element by element. Very simple. Look at my table. Nitrogen, if you take, how many atoms of nitrogen are there on the left? 1 into A, because A, ammonia. So see, A. How many atoms of nitrogen on the right? 2 into C plus 1 into D. Can you see on the right hand side, it's going to be 2 into C. So A equal to 2C plus D. Similarly, you form the other equations. Basically, in all of these, you are counting the number of atoms for each of these elements on the left and on the right. And you're just writing it. Clear? Excellent, guys. And so then you solve this, and then you have to only substitute. So let's go ahead and substitute our numbers. A, we are going to substitute as 4 by 3. So A is 4 by 3 here. What is B? Well, let me write it in green. We have solved the colors in green here. So 4 by 3 here. B is nothing but half. So I'm going to put half here. C is nothing but 1 by 6. So let's put 1 by 6 here, guys. Very simple. We just solved it. And D was, let's write the 6 clearly. So C is 1 by 6 and D we took as 1, because the guy with the most number of times occurring in the equations we took as 1. Now this is our balanced equation, but they are fractions. So to get rid of the fractions, we need to multiply by 6 here, right? Because by multiplying by 6, we'll get the fractions will get removed. So let's multiply our whole equation by 6. So 4 by 3 times 6 is going to be 8. So this is going to be 8 here, right? Or let's leave this here and let's write it in our final answer. So we are going to balance this whole thing. So 4 by 3 times 6, this is going to be 8 here. Half times 6, so we are going to get 3 here, right? And then 1 by 6 times 6, so nitrogen is going to be 1. And 1 times 6, so this is going to be 6. And this is our final balanced answer using the ABCD technique. Excellent. I see Jemmy Alex has the right answer. Uttam Kumar Biswas, very good, guys. You guys solved it. Excellent. And so this is the technique. You can even probably solve it with hit and trial or the table technique. But this ABCD method is very powerful. It's foolproof. You just have to carefully write down the equations using these coefficients and solve the equations. And they're not difficult to solve because they are small numbers, okay? And just in the end, you must make sure that you don't have fractions, because you can get fractions when you solve the equations. So just multiply it by the appropriate number, which was 6 here. And our final answer is 8 ammonia plus 3 chlorine plus equals nitrogen plus 6 ammonium chloride. And there you can see that no common factor. We don't have anything like, you can't divide all the coefficients by 2 or 3. So there's no over multiplication. It's clear and it will, so our answer is absolutely right. Okay. And if you have a doubt, you go through this. Otherwise, watch my watch my video on balancing equations. There also I have covered the ABCD method in detail. Very, very powerful method. So my recommendation, go for hit and trial. Otherwise, it's tough. Go for ABCD to balance the equations. Excellent, guys. Another question for you. Write the chemical equation for the reaction of aluminium and steam, and also write down the physical states, which means solid, liquid, aqueous or gas. So come on guys, I want all of you to try writing this equation. Very good. So come on, what do you think is going to be the reaction for this equation? All of you trying? So let's analyze here. What do we have? So reaction of aluminium and steam. Okay. Steam, you know, is water. Okay. And what do you think you're going to get here when you react these two? So come on guys, can you first think about aluminium plus steam gives you what compounds? Can you guys try? Okay. No worries if you don't know. These equations are given in your textbook also. So I want all of you to try and please practice the equations that are there in your book. Okay. So come on, try. So here a couple of options, right? Either it can give aluminium hydroxide or aluminium oxide, right? So those are the possibilities. That's the part you need to learn. Very good. I see Jay Reddy is writing aluminium oxide plus hydrogen, right? Abhishek is writing that. Excellent. Okay. Very good, guys. So here it's going to give us aluminium oxide. Okay. So this is basically going to give us, so first let's write it in words. Aluminium oxide plus hydrogen. So that is our answer. Okay. So what is the formula of aluminium oxide? It's a compound. So Al and O, aluminium valency is 3, oxygen is 2. So if you do crisscross, aluminium oxide is basically Al2O3, right? So our equation is going to become Al plus H2O, right? Is going to give us Al2O3 plus hydrogen. Now hydrogen is an element, so we are going to use its atomicity. Atomicity is 2, right? So everybody clear about this? Hydrogen, the atomicity is 2. So Al, yeah, so this is the part where you need to learn that will it produce aluminium. So very good, some of you predicted hydroxide here, but when it reacts with steam, it actually produces the oxide of aluminium. Okay, so please remember that. Now the last thing is, of course, to balance the equation and to fill in the physical states. Okay, so come on guys, let's quickly balance this equation with the hit and trial. So you can see that aluminium is 2 here, so let's put 2 here. And what else we have left to balance? Oxygen is 3 here, so to balance it we'll put 3 here. So oxygen is balanced. Hydrogen, how much we have on the left? 3 times 2, 6. So we'll put 3 here. See, it's pretty simple. So you don't have to go for fancy ABCD and all. Just by hit and trial, you can balance it. Excellent. Yes, Isaac Newton is also saying Al2O3. Very good, guys. Superb. Okay. So this is the correct answer, right? Al2O3 plus hydrogen. Now, guys, don't forget, because many times we feel we've got the right answer, we need to write the physical states also. So what is the physical state of aluminium? Can you guys tell me? Come on. I want everybody to try. So what should I fill in the physical state of aluminium? Help me out here. Come on. Okay. Where do I live? As I said, I am from Kolkata, India. Okay. And excellent and great to see a lot of folks here from India and also from all around the world, right? So thanks a lot for joining us, and do share it out with your friends so that we have more people. So very good. Aluminium is a solid because you know aluminium is a metal, right? So we'll put solid here. Simple. What should I put the state of water here? Should it be liquid, aqueous or gas? Can you guys tell me? In the reactant, what should water be? Come on guys, tell me. Gas. Very good. Not liquid, because look here, very important clue, it is steam. Steam, you know, is the vapor state or the gaseous state of water, right? So this needs to be gas. Please remember this important thing. Steam is a gas, so don't say, oh, water, let's put liquid. Okay, be careful. Now guys, what is the physical state of aluminium oxide? So who can tell me? Excellent guys. A lot of you are saying gas. Very good. So keep it in mind because this is steam, right? So guys, what should I write for aluminium oxide? Aluminium oxide, this thing I'm asking, what should be the physical state of this guy? Al2O3. Okay. So guys, Al2O3 is aluminium oxide. So usually the oxides of metals, they are solids, right? And here there's no water involved. So we don't have to be worried about dissolving in water because there's steam, right? So this we can write safely as solid. Okay. So this is going to be a solid because it's a aluminium oxide, oxide of a metal. And last one, hydrogen, you know, very easy. Hydrogen is definitely a gas, but don't forget to write H2 because one molecule of hydrogen contains two hydrogen atoms, right? So here is our final answer. Can you see the final answer here? So this is our final answer. 2Al plus 3H2O gives Al2O3 plus 3H2. So did you get the tips and tricks of writing the equations? Write down the elements and compounds carefully using atomicity, valency. Then you need to apply your physical states, and don't forget to balance the equation. Because you know, I remember our school teachers used to give us 0 for the equation, even if the equation is correct. But if you forget to balance it or you balance it incorrectly, you don't get any marks for the equation. Okay. So guys, please remember that. Which law is used for balancing equations? Panda PUBG is asking. So you know, balancing is based on law of conservation of mass. Okay. We are counting the atoms, but finally, what are we balancing? The mass of the reactants is equal to the mass of the product. So good question. This is based on the balancing of equations is based on the law of conservation of mass. Okay. So that is why we balance the equations to satisfy the law of conservation of mass. Clear? And guys, I have one more question for you for homework. So what is formed on the corrosion of silver? So one important thing to know is that corrosion is not only for iron. So rusting of iron is a great example of corrosion. What does corrosion mean basically? Corrosion means when the metal is eaten up, right? So when the metal gets corroded, eaten up due to exposure to air and other chemicals, right? Even acids, right? So metal gets eaten up. And what do you think is formed when silver gets corroded? Is it silver oxide, silver carbonate, silver sulfide, or silver carbide? Okay, I see a lot of answers here, but guys, I'm not going to tell you the answer because I want each one of you to try it. And do let me know your answer in the comments below, and I'll try to respond to your comments as soon as possible. So thanks a lot, guys, for joining us for this session. So please try this homework question. And as I said, do check out our website, manochaacademy.com. We have big discounts going on these courses. So hope it'll help you in your preparation. And we'll soon be launching the Maths Class 10 course this week. And next week also we'll launch the Maths Class 9 course. So guys, please be ready to see the maths courses also, and do take a look at them, and do join us, do join these courses because they'll really help you in your preparation. We have interactive videos, quizzes and questions, and more live classes on our website as well. So I'll put the links below, and thanks a lot for being so interactive. And guys, if you haven't subscribed to our YouTube channel, what are you waiting for? Hit the subscribe button right now, click on the notification bell, and please share it out with all your friends. When is the next live class? Usually I'm taking the live class at 8 p.m. Daily on YouTube, and we have the live classes at 6 p.m. on our website. So guys, do check it out and hit the notification bell so that you don't miss out on these live classes. And these courses, as I told you, we have big discounts going on. They're really good prices. So because we want more people to sign up on these courses and benefit from them, right? So this is all for you guys. And thanks for joining the Manocha Academy family. Big thanks from our team because it's awesome to read all your great comments, and we just love to hear your feedback. So thanks a lot, and do put in your feedback for this live session as well, and what topics you'd like covered. So I'll try to take some more live classes based on your feedback. So thanks a lot, guys. Yeah, the live class on YouTube is at 8 p.m. every day. Excellent, guys. So come on, do hit the subscribe button and share it with your friends, and please give me a like for this video. I really enjoyed it. You guys were extremely interactive. Thanks a lot for joining, and please take care of your health. I know this is a difficult time for all of you, but during this lockdown period, please take advantage of this time and do your preparation and studies well, because you know class 10 is important, or you're in class 9. Anyway, you should be studying well and also relax well, right? So have a good timetable, have a balanced thing where you're studying also and you're having some relaxation time. So I wish you good health for everyone. I pray for everyone's health, and thanks a lot for joining. What's my name? I already told. My name is Sandeep Manocha. So Sandeep Manocha signing off. Thanks a lot, and do keep watching our videos on Manocha Academy channel, and check out our website. All right, guys, take care. Bye. Okay, bye-bye.